if f is a function from x to y and g is a function from y to z, and g of f is 1 to 1, must f be 1 to 1? Prove or give a counterexample. Now, I'll be honest, it's really hard to judge whether or not these are true statements or these are false statements unless you go through a couple examples. I'll show you one example. We need to think of an example of functions f and g such that g of f is 1 to 1. So I need to think about a function inside of another function that's 1 to 1 that passes the horizontal line test. Now, I could think of a function inside of a function like x plus 1 cubed. Now, this is a cubic function, and it's a special cubic function that passes the horizontal line test. So this function is 1 to 1. The question is f 1 to 1? And the answer is yes, x plus 1 is a 1 to 1 function. If you graph this function, it looks like the equation of a line, and that passes a horizontal line test, since it's not a horizontal line. Now, I'm wondering, can we replace this x plus 1 with something that's not 1 to 1 and then get a 1 to 1 result? Because if we can, that would be a counterexample. If I plug a function that's not 1 to 1, I'm thinking of something like x squared, and this is from r to r. This doesn't pass the horizontal line test from r to r. But x squared cubed is really x to the 6th, which also doesn't pass the horizontal line test, which tells me that the moment we make this inside function not 1 to 1, then the composition is no longer 1 to 1. And that leads me to think that this statement is true. So let's try to prove that it's true. To prove that f is 1 to 1, what I like to do is proof by contrapositive, or sometimes some people refer to this as a proof by contradiction. We're going to assume that f of x1 equals f of x2. Now, these are both outputs, f of x1 and f of x2. They're outputs of the function f, which are elements of the codomain of f, so that's y. And since that set is the same as the domain of g, that means we can plug these elements into the function g since they're elements of the domain of g. So what I'm going to do is I'm going to plug both of these elements into g. This means that g of f of x1 equals g of f of x2. Now, g of f is assumed to be 1 to 1. I should mention we are doing a direct proof, so we're assuming that g of f is 1 to 1 here. Here I have two inputs that correspond to the same output of g of f. But g of f is 1 to 1. But since g of f is 1 to 1, then that means that these inputs x1 and x2 have to be the same. And so we have proven that if we have f of x1 equals f of x2, that must therefore mean that x1 equals x2. But really, to show this, we have to use function composition with g, and we have to use the property that g of f is 1 to 1. Without this property here, we wouldn't be able to reach this conclusion in any way. So therefore, this function is 1 to 1. Thanks, everyone, and I'll see you in the next video.